Assalamualaikum semua. We are back, still under normal distribution, but part 2 of the video. Right. Okay, so in this part 2, we'll be trying to cover example 11 and 12. Okay, but before that, you need to attempt investigation 10 on your own. Okay, and try to find out some symmetry involved. Okay, so you can do that first. Okay. Let's look at example 11. Okay. They say that x follows a normal distribution between 21 and the variance 9. Okay. Find x given that probability x is less than x is 0.8. Okay. So all this while, right? Okay. We are given the x here, and we are supposed to find the probability. Okay, using our GTC. But for this part, okay, we are given the probability, we are supposed to find the x. Okay, so to do that, okay, you will need to take out your GTC. Okay, so take out your GTC. Okay, turn on your calculator. Okay, for the first one, okay, in the book they just say the answer is 23.5. So how do you do that? Okay, what you need to do, press second bars. Okay, again, you will arrive at those normal whatever distribution over there. But for this case, you need to do inverse norm. Okay, inverse norm is calculating the inverse. Okay, calculating the x. Okay, so press inverse norm. Okay, area. Okay, area in the probability density function will is actually defined by the probability. So if probability is 0.8, that means the area under the graph is 0.8. So key in 0.8 under the area. Okay, mu is the mean, so we'll key in 21. Standard deviation, again, don't be tricked, this is variance, so standard deviation is 3. Okay, press paste it into your matrix, press enter. That's how you get the x, okay, to be 23.5. Okay, this is from GDC. Right? Okay, for the second one, part B. Okay, we are given probability x is more than x, okay, to be 0.4. Okay, so again, our GTC only calculates probability less than, not more than, so we cannot key in 0.4. Okay, what we have to do is we have to key in the area to be 0.6. Okay, so let's do that. Okay, let's inverse now. Press now, and okay, the area will be 0.6. Okay, and then after that, the mu is 0.21. Okay, the standard deviation is 3, and you paste it. Okay, so you'll get your x to be 21.8. Let me draw that graphically. In the probability distribution probability density function, okay, if probability x more than x is 0.4, so that means, let's say here, this area is 0.4. Okay, so at this particular point onwards is 0.4. So at this particular point backwards is 0.6. But the particular point is the same point, 21.8. Okay, so if we were to calculate probability x minus x, okay, for this case, all you have to do is find the opposite, get the complement, and you will still be the same number. Okay, so that's how we get for part B. Okay, so for part C, I will have to erase everything first because it's a totally different question. Alright, we are still doing question 11, example 11, but question 2. Okay, let's read the question first. Find A and B given that probability x is more than A but less than B is given at 0.68. Okay, but there are more information. A and B are an equal distance either side of the mean. Okay, so let's try to make sense of it. This is the probability density function. Okay, the mean is always in the center, mu. Okay, and they say that A and B is of equal distance. This is A, this is B. Okay. Equal distance from the mean, okay, on either side. Okay. So what this means is that if this is the mean, right, okay, and the probability of it being between A and B is 0.68, that means this portion will take up half of it, which is 0.34, and this portion will be 0.34. Okay, okay, so now what you can do, okay, is, let's try to make sense of it. If this is 0.34, okay, and this is 0.34, okay, what's the probability of x less than b from here onwards? Okay, you see, probability x is less than mu, the mean is always half. This part is half, this part is half, right? So this probability x is less than b will be half under here, the mean, after that plus another 0.34. So x less than b is 0.84. Okay, 0.5 plus the 0.34. Okay, when you get this, okay, it goes back to your question 1, okay, whereby you're supposed to inverse norm and get the value of b. Okay, in this case they say that b is 24. Alright, okay, so to calculate a, right, okay, you don't really have to calculate the probability again. Okay, there's actually a trick. They say that the a and b are equal distance from the mean. Okay, the mean is given as 21. Okay, so if b is 24, right, okay, so that means it's 3 units after the mean. Okay, so that means a must be 3 units before the mean. Okay, so 3 units before 21, so it's 18. Okay, that's how you calculate the a. Right? Okay, we finish question 2 part B first. Okay, verify that this supports the statement that approximately 68% of all data for a normally distributed population is likely to lie within one standard deviation of the mean. Okay, so let's make sense of the long sentence. Okay, you're supposed to verify, okay, that 68% of all data, okay, for a normally distributed population. So this is a normally distributed population. Okay, and then you want to see whether the probability is 68%. You notice that this 0.68 is the 68% there. Okay, and then they must lie within one standard deviation of the mean. So this is the mean. They must lie one standard deviation away, whether be it to the left or to the right. Okay, less than the mean or more than the mean. Okay, so now our b is 34, our a is 18. Okay, so we are 3 units away backwards and 3 units away forward. Okay, but 3 happens to be, this is variance 9, right? But standard deviation is 3. So 3 happens to be our standard deviation. Okay, so that means the two values, okay, these two actually falls within the range of 21 plus minus 3 or plus minus 1 standard deviation. Okay, therefore this supports that 68% of the population must lie within one standard deviation away. Okay, right. So we are done with example 11. Okay, we'll continue with example 12. We are back. Okay, we are now doing example 12 on page 599, okay, of your textbook. Okay, Maths Application and Interpretation, HL level. Okay, so now let's look at the question and we read it first. Okay, the weights of cauliflowers, okay, purchased by a supermarket from their suppliers are distributed normally with mean 821 grams and standard deviation 40 grams. Okay, so let's write that down first. Let W be the weight, right? Okay, of a randomly selected cauliflower. Okay, then W follows the normal distribution. 821 is the mean, and then the variance will be 40 squared because this time you are given the standard deviation. This will take note. When you're given variance, you write variance. When you're given standard deviation, do make sure you change it back to variance. Okay, right. Cauliflowers weighing less than 750 grams are classified as small. Okay, A. Predict the number of cauliflowers classified as small in a sample of 400 cauliflowers. Okay, so you have done all your normal distribution and stuff. Okay, find expected number of cauliflowers. Okay, cauliflowers. Okay, that is classified as small. Okay, first is you take your 400 because the sample is 400, and then you multiply by probability W is less than or equals to 750. Okay, so to calculate this, okay, we just use our GDC, okay, and key in the mean and key in the standard deviation, okay, and then we will get the probability, and then we will multiply it by 400. It will be 15.1796. Okay, even though there's this feeling that we should actually round up to become 16, but the probability of this 0.17 here, right? It doesn't bear much of a difference. So we predict that 15 cauliflowers will be classified as small. Okay. Okay. So now we go on to part B. Okay. Now we have classified the small one. Now we are going to classify the heaviest one. Okay. The heaviest 8% of cauliflowers are classified as oversized. Okay. And repackaged. Find the range of weights of cauliflowers classified as oversized. Okay, so I'll erase this first. Okay. Now we are doing the oversized one. Okay, to understand the question, it's best for us to draw the probability density function. Okay, so our mean here is 821. Okay. What happens here is we want the top 8%. So that means, okay, the probability of it being more than that particular value, let's say A, okay, this portion will be 8% or 0.08 in terms of probability. Okay, so now you are supposed to find what's the A, okay, given that the probability of it being more, okay, is 0.08. Okay, so that means the probability of it being less, okay, this is W. W being less than A, okay, must be equals to 1 minus 0.08, so which is 0.92. Okay, so it goes back to the question whereby you're supposed to find the value of A given the probability. Okay, so you're supposed to use inverse norm, okay, and inverse norm will give us your A to be 877, okay, grams. Okay, so that's how you attempt example 12. Okay, most of the time using GDC, so make sure you know how to use your GDC. Okay, you'll be carrying on with your homework, okay, which is from exercise 13D. And remember, teachers, you don't just teach professionally, you teach professionally.